So at first, if you click on this link right here on this particular slide presentation, when we went to Abstract Factory, there's this link to Abstract Factory, which brings you over here to the front page of Abstract Factory demo program. This is where we downloaded everything. So right now, in our project, what we do is that we actually construct an object which uses a simple maze, and that's what this Boolean variable indicates. Another type of maze would be a maze with walls that can be bombed, and that's a different story. So let's take a look at this a link right here, simple maze. All right, so this is actually the type of work that is happening here. Well, first of all, this specific documentation actually gives us an inheritance diagram between different classes that are present in this project. Notice that everything derives from an object. Well, I will tell you a little secret behind this design, is that the actual design is put together in such way that you can, in fact, take this project and quickly move it to from C++ to Java. It doesn't use anything that Java doesn't have in order to for the sake of the design pattern demonstration. And like I told you, it should be a very straightforward path from C++ project to Java. So anyway, there is an idea is that there is an object. In fact, we could quickly find in our project where that object is, right? So apparently there's an implementation file for object, and here's an implementation file for an object, and apparently the object can print stuff, right? And if I look at the object header file, right here is class object, and so the object has the constructor, the object has a virtual destructor, and the object has a print method which basically prints an identifier that an object stores privately. So for this reason, I wouldn't be shy to jump to my drawing right here and clean this up, and this time maybe try more careful, trying to actually go ahead and try documenting what I see over here, right? So an object, an object is a class. Object is a class. It has the data attribute named ID, right? I will keep the spelling like uppercase, lowercase type of thing. In UML, the types are expressed actually not in front of the name, but after, right? So we can say it's an int. I will just try to use print typeface to make it easier to see, right? So over here we have the constructor. You can write constructor as new over here. I prefer to use the word new on my UML diagrams to demonstrate the presence of constructors. And this constructor actually accepts an ID, right? Which is also an int. So it's kind of easy to understand that what happens here is that this specific, in fact, let me get rid of this line right here, right? So this specific class named object has one data attribute, and it has the constructor, and it also has the destructor, which I will skip right now for the sake of simplicity. And it also has a method named print, right? Print, which takes some level of indentation, which can be also default value of 0. So this is a method named print, and I will just simply keep it keep it like this. So if I was just to design this class in my mind or on the whiteboard, this is the way I would represent it, and this is essentially a UML notation for a class. So class has a name, class has a set of attributes which go to this section, right? So if I want to highlight this section right here, this specific section is for the attributes, okay? And the following section, right here, the next section is actually for a set of methods, right? So we have basically an object name, or actually class name right here, and then we have the a set of attributes, and then we have, of course, a set of methods. Basically, the attributes represent the state of an object, and the methods, including constructor, represent the behavioral part of our object. So, very simple object. It has ID. Constructor will take the ID, and apparently the print method, I wouldn't be surprised if I went back to this implementation file right here and found out that what print says is that it says let's just display some white space indentation. Remember, when we run this program, you see how each thing that gets printed gets indented with a certain level of white space, which is different, and that's what the indentation does for the print, right? And it's using print C library function to display the ID of an object and so forth. So anyway, so this is what the object does. It's really simple. We should be able to also jump to the definition of print indent, and print indent simply uses for loop that says give me the number of spaces that you want, and it basically says print a space. This may not be very efficient. There may be better ways to do indentation, but this is very simple, right? And in fact, this sits in a global.cpp file. So there are obviously many files that this thing is coming with. So the main function, of course, this is a C++ project, so it comes with the main function. So it doesn't hurt to actually look at the main function and realize that it wants to create a maze, but at the beginning it doesn't create anything. It just essentially declares a variable that is pointer to maze and doesn't create the maze, right? Then it wants to create a maze game, right? And says new maze game. So maze game apparently is a class that represents the entire game. So if we, for instance, decided to keep some business rules related to the implementation of this game, this would be part of the maze game. And so fortunately, the names of files here kind of complement the name of classes. So if I double click this and open it and jump to, say, open document mazegame.h, which is the header file where it's declared. So here's another class that I can actually document and try to envision right here. Obviously, I will not be coloring my diagrams like this. This is just to do the demonstration. But here we go. The maze game is another. Let's switch to this color, right? So maze game is another class in this software that apparently represents the entire application or entire set of rules for the game. And what it does, again, it actually, I don't see that it has any data. There is no data. But even if there is no data, the section which is responsible for preserving the data is still left visible. And it has the constructor, which doesn't take any parameters. I will say new over here as a name of the method instead of repeating maze game as we do in software. Then we have the destructor, which I will now ignore. It has a name it has a method that says create maze. Okay, so interesting. Create maze returns the maze object, right? So it has the method named create maze, right? And this is how I can document it. And in UML, so it takes actually maze factory, which will be responsible for creating it. Create maze, so it actually takes a factory. I just say F, and the type of this parameter is a maze factory. Okay, so this is another method that maze game has. And finally, it has also a print, right? So there's also its own version of print. That's what the maze game has. It's a relatively simple object. So, and this is how it looks like, right? So again, I will complete my box with drawing all the sections here. And by the way, the source code also tells me that it inherits from object. So in Java, we say extends. In C++, we say colon public, and that's the normal way of inheriting. So therefore, maze game actually inherits from the object. So that's maze game. My choice for these classes is simply because my natural instinct tells me that if I want to understand a little bit of like what's going on, I can go to like the driver program here, and the driver program will basically the main function tells me what is happening at this level, so I can basically try documenting what's going on at this level. All right. So let's save this and move to a different room so we can continue looking at this design pattern and this little project demo.